How do you plot a polar equation? Okay. What's a polar equation? A polar equation looks like R equal to A cos theta, where you can put some value of A. You can say A is equal to 4. So R equal to 4 cos theta is a polar equation. This is a polar equation. We want to plot this. So how do we plot it? So understand the plotting of polar equations, polar curves. So how are they plotted? It is plotted on the basis of r and theta. What is r and what is theta? So remember, if this is your xy plane, then consider a point. Say this is the point x comma y. Then corresponding to this point x comma y, we have the vector. The vector has the magnitude as r, and the angle made with respect to the positive x-axis is theta in the anti-clockwise sense. So for this point A, if I say the point is A, is same as saying that A is a point and its coordinate is xy, is same as saying the point is situated at a distance r from the origin and with some theta angle from the positive x-axis. So either we are given the coordinates x comma y or we are given r theta. It is the same, we can plot the points. So how do we plot the points over here? Is that r is the distance from the origin and theta measures the angle of the vector OA with respect to the positive x-axis in the anti-clockwise sense. That sense is the clockwise sense. So if I have an equation like r equal to function of some r theta, r equal to f of theta. So how do I plot the points? So if I know some points on this, so let's say we have a table and we want to plot some points for corresponding to r and theta. So how do we plot it? So suppose say we have theta equal to, we fix theta. Suppose theta is 0, 30 degrees, then 60 degrees or 45 degrees. And corresponding to these values of theta, we calculate some r and we get some, for suppose, okay, let we have it as 1, 2, 3 and 4. We have these values of r and these are the values of theta. Then how do we plot the points corresponding to this r and theta? So we have this initial line which is called as a theta equal to 0 degrees. We have the line theta equal to pi by 2. We have the line theta equal to pi and we have theta equal to 3 pi by 2. Right? So in this, if I want to plot the first point, this is my first point. The corresponding values are, information is theta equal to 0, r is equal to 1. So this is my line theta equal to 0 and on this at a magnitude r equal to 1, we have to plot this point. So this is my first point, I will call it as P1. This is my P1. To plot P2, I have to go on an angle of 30 degrees. So suppose this is my line. This is theta equal to 30 degrees. Suppose. So on this vector at a distance of 2 magnitude plus 2. So I have to measure this distance. This distance should be plus 2. So if this is 2, then my point P2 is this. So this is my corresponding point P2. Then we have theta equal to 60 degrees. Or suppose I have another line. This is theta equal to 60 degrees. On theta equal to 60 degrees, I have to map the point at r equal to 3. So on this line at a distance r equal to 3, this will become my P3. So this distance will be 3. and then I have theta equal to 45 degrees, 4, and so on. That's how you map the points, right? Now our target here is to plot the rose curves. The rose curves. The well-known rose curves are denoted by the equation of the kind r equal to a cos of n theta. N is any value, b is any value, or a is any value, or r equal to a sine n theta. You can change the value of a and n. So let's say I want to plot r equal to 2 cos 4 theta as an example. So what do? We have to fix some values for theta. So I have to give some values to theta. Theta value I choose from 0 to 2 pi. In the range of 0 to 2 pi at a certain distance. Okay. We have to calculate the values of, for these values of theta, we have to calculate the corresponding values of r. And then we need to plot these values of theta and r. Okay. In Scilab, what we do is your background. In Scilab, what we do is we define a theta. We define a theta. Theta is equal to 0, 0.0012 into pi, 2 pi. R is equal to 10 into or 10 or 2. Okay, we are doing with 2 into cos 4 theta. Semicolon important. And the last step is polar plot. Theta r. So execute this in Scilab. Let's have a picture of the well-known rose curves. Let's say we want to plot our rose curve. Okay, we want to plot our rose curves. Whose equation is r equal to 2 cos of 4 theta. Fine. So our first step is clear the figure window, Scilab. Then I take a theta and I define its minimum, maximum, and in between values. It will be from 0 to 2 pi plus with the linear spacing of 0.001 to 2 star percent pi. Pi is a special character, so percent pi. Then we have r equal to 2 star cos 4 star theta. 4 star theta. A semicolon again. Then I say polar plot. So polar plot what? Theta and r. First theta, the angle, and the modulus, and semicolon. Now I need to save this by a specific name and then I'll run the code. So I save this with the name of polar rose curve. Save.sce. And here we are. get the rows curves. For cos, I have this beautiful curve. I have this beautiful curve for r equal to 2 cos 4 theta. I'll just fix this. Once I dock this is docked, so I get the graphic window and the code window side by side. Now what I will do is I'll change my cos. Instead of cos, I will make it sine. So what do I get? I run the code, so I get this. Okay, 2 star 4 theta. So I get 8 petals in this. These are called 8 petals or 8 loops. If I take 3, so I get 3 only. Okay, even if I have cos 3 theta, I get 3 petals only. That's the position of the petal is same. So what do you understand? So before making any conclusions, I'll just run this for 5. I get 5 petals. If I take 6, I get 12 petals. So what do you understand? When it is even, and 6 is even over here, then I get double the number of petals. And if it is odd, and I get the same number of petals. So you can dig into deep and why it is that way. You can clarify that. So this is about plotting rows curves. Small code for plotting rows curve.